Good afternoon to all. So today we will be talking about the topic called the turbocharging. Uh, so these are all the contents that we will be seeing in turbocharging. So we will be seeing the fundamentals of supercharger and turbocharger, and then the efficiency wise. You have components called compressor and turbine, and we'll be seeing the efficiency of these things. And we'll be seeing the fixed geometry turbocharger, wastegate turbocharger, variable geometry turbocharger, and how we are going to match the turbocharger with respect to the speed, pressure, wise, and how we are going to match, how we are going to select the turbocharger, basically with respect to the speed, and then with respect to the pressure ratio, and then with respect to the efficiency point of view. Okay, so we have seen the definition of a volumetric efficiency, okay, which is defined as the ratio between the mass flow rate of the air to that of the volumetric, it means the displacement of the engine. Okay, so here I can also put this volumetric efficiency as the power output of an engine, uh, which is directly depending on the amount of charge. So it is nothing but the air. Okay, so this turbocharger and the supercharger will also increase the power output of the engine, and thereby the volumetric efficiency of the engine will get increased with the help of both supercharger and turbocharger. So basically, the main objective we want to go for this turbocharger is basically to increase the power output of the engine. Okay, and that will have the direct influence on increasing the volumetric efficiency. Uh, this mass flow rate of the air. Okay, this will get improved when you are going for a turbocharger one, because you are forcing the air uh, in a very by inducing the pressure into it. Okay, so by that concept, so you're also going to increase the volumetric efficiency using a turbocharger. So you have seen the volumetric efficiency as the ratio between the actual mass of a charge which is injected into the cylinder to that of the theoretical mass of the charge which is being injected. And so the main objective of going for this turbocharger is to increase the mass flow rate of the air, which means the actual mass of charge detector gets increased, thereby the volumetric efficiency of the engine also gets increased. And if you're going for naturally aspirated engine, which means without turbocharger, we have seen the efficiency is the volumetric efficiency 80%, and the volumetric efficiency gets increased to 95 to 98% when you're going for supercharging or turbocharging methods. We have also seen there are many ways to improve the volumetric efficiency. So by modifying the intake manifold passages, by eliminating the bends, because if you have bends inside the intake manifold, what happens is the air which is coming inside, it gets restricted because of this type of sharp bends. Okay? And the walls should be smooth basically. If you don't have the smooth walls, then this will affect the volumetric efficiency of the engine, and you should not have any obstructions. You have the walls it should be relieved from the very rough surface. It's very smooth actually, and all this will have the influence on affecting the volumetric efficiency. And if you go for the turbocharged version, apart from this the design improvement, so this turbocharger will also help to increase the volumetric efficiency of the engine. Okay, so we will see the airflow requirement basically. Okay, I told you for any combustion to take place, you need oxygen, and you're going to get oxygen in the form of air. Okay, air contains oxygen, nitrogen. Okay, uh, air is a very precious thing for the combustion to take place. And we engineers we calculate the engine airflow requirements using three factors. One is the engine displacement. Uh, okay, the displacement of the engine, and then the engine revolution based on the RPM, and also the volumetric efficiency. These three methods are being factors are being very much important to calculate the engine airflow requirements. Okay, and you know how to calculate the engine displacement, which is nothing but pi by 4 is for L, where D is the diameter and L is the stroke length, and you know RPM, engine RPM, or what speed the engine is operating, and you know the volumetric efficiency. Okay, how much is the mass flow rate over here, which is vectored into the system to get out the theoretical mass. Okay, as I given the volumetric efficiency definition, so this always we need to focus on the airflow requirements. Okay, how much is the amount of oxygen basically it is coming out of the air is required for the complete combustion to take place. Okay, it means for the fuel burn in a much more manner, such a way the air fuel mixture is been optimized, and you are not going for a abnormal kind of combustion where you have only less air and more fuel. So if you're going for a rich mixture where you have more air, more fuel and less air, then it leads to incomplete combustion. Okay, so we need to ensure that we have the proper amount of airflow requirements. Um, and you know this we have a stoichiometric mixture, and we have the lean mixture, we have the rich mixture. We need to ensure that uh, the proper airflow requirement is there for the complete combustion to take place. And see, normally the volumetric efficiency is set as a percentage, and it will also vary with respect to the engine speed. Okay, see the volumetric efficiency is not going to be constant. Okay, it increases in the engine speed. Okay? At the ideal RPM, the efficiency will be lesser. Okay, and see, basically this turbocharger will help to increase volumetric efficiency because when the engine is running in low idle RPM or low RPM, what happens is the air which is going into the engine will be lesser. So, such a way, this the airflow requirement will be get matched with the help of the external devices like the turbocharger. Okay, this is the turbocharger arrangement entire the engine. Okay, so we'll see the concept, basic concepts of supercharger. Then I will come back to the turbocharger. Uh, you see, this is the two thing. One having the low density, another is having high density, and I will tell what is the density is all about. Okay. See, density is the density. How we can define density? Okay, density is defined as the mass of the substance in a given amount of space. What is the mass? Okay, uh, the mass of any object. It can be any object. Okay, it can be the liquid, or it can be the gas, or it can be the vapor, whatever it is. Okay, so density is defined as the mass of the substance. Okay? It can be in the form of liquid, or it can be in the form of gas, or it can be in the form of vapor. Okay, and what density we are going to consider here? Okay, that is very much important. Here we are going to consider the air, because I said the air is very much important. We need basically oxygen, okay, and which is coming out of the air. And you see here the amount of force on air fuel charge position, which means the air fuel mixture, okay, produces when it is ignited is largely a function of a charge density. Say for example, when air and fuel gets mixed up, you get the combustion out of it. Okay, so here you have the combustion. It is nothing but and it is nothing but the function of a charge density. Okay, so here the charge density, you're going to increase the charge density, which means you're going to increase the combustion, which means you're going to increase the amount of air or oxygen going into the cylinder, and this is where the principle of this supercharging comes into picture. And this normally the main objective of going for this supercharging principle is we need to increase the pressure. Okay, and basically you see it is the graph where the pressure of the atmospheric pressure basically. Okay, it means the air which is coming from the atmosphere. You see here when the altitude gets increased, this is some of the different samples. In New York City, you have 14.7 psi, and in the case of 10 2 is where you have 600 feet difference between these two places, and you see the pressure is getting reduced. Okay? And still, you see when you have the height of 5,000 feet, you have only 13 psi. And when you have a feet of, and when the altitude gets increased 14,000 feet, you get lower pressure. Okay, which means the atmospheric pressure decreases with increased altitude. And here, what happens is you are going to take the power from the engine, and this will help uh, you to ensure that you are having the sufficient amount of pressure for the engine for the vehicle to operate. Okay, which means we are increasing the power output of the engine. Okay, so now we will tell why we need to go for a turbocharger or a supercharger. We're going for a full screen mode. Okay, uh, we need to we need to have a supercharger and turbocharger basically to increase the output of any. Okay, so I told you you need to go for the power output. Okay, higher the power output, you get higher efficiency. So in order to increase the power output of the engine, what you need to have is you need to have the more fuel that can be burnt, and it will help for better combustion. Okay, and this needs to be repeated in each and every cycle. Okay, I told you the cycle is the repetition of the complete one complete stroke. Okay, from intake, and then you have the compression stroke, and you have the expansion, and you have the power stroke basically, and the last one is exhaust. This forms one cycle. You need to get the power output of the engine each and every cycle. It is not that you are going to stop your power output of the engine after 3 cycle or after 5 cycle. But this should happen throughout your lifetime. Till your vehicle gets stopped or your engine is in stopping condition. Okay, when the engine is in on condition, throughout throughout the time when the engine is in on condition, even throughout the cycle time, which when it comprises of each and every stroke, it is very important to increase the power output of the engine. Okay? Uh, and that is possible only when more fuel can be burned, and you can burn the fuel only if you have the explosion or combustion that is possible with the help of air. So here we will see how we can ensure that combustion is going to take place so that the explosion will happen. Um, so here one way is to add the power. We are going to add external power engine basically. Um, Again, it also depends on the engine size. You have different sizes of the engine as well. Smaller size, big size, medium size. Okay. When you consider some bigger engine, okay, which will also it is having more weight and more cost to build, and again, this is very difficult for the bigger engine to get the power to get developed. Okay, in such case, this external device like a supercharger and turbocharger will help actually. And another way how we can add the power is by for a normal sized engine. Okay, this is for the bigger engine I told. This is for even for the normal sized engine. This system of turbocharger and supercharger will help a system to be more efficient. And this is possible by forcing more air. Okay, here the air which is coming from the atmosphere is being forced more into the combustion chamber, and this forcing the induction force is coming to the intake manifold is being induced such a way the induction principle by the way supercharger will help to uh, take the air in a forced manner. Okay, in a forceful manner, it will take into the combustion chamber. So again, I told you, more air means more fuel can be added. Okay, so still yes, you need to have more fuel to get the more power out of the engine. Okay, and especially you need to have you'll be having the issue when the engine when the vehicle is running in higher altitude. Okay, where you have less air. Okay, and and again there this bit the importance of the supercharger and the turbocharger is much more still comes into picture. And okay, we'll see somehow we'll see the definition of it. How we can define the supercharger. Okay, the supercharger is nothing but it's an air compressor. Okay, it will compress the air. Okay, so it's a type of air compressor. It is used for forcing the induction of an internal combustion engine. I told you the air is being induced into the engine forcefully. Okay, even in the case of turbocharger as well. Okay, so it is the forced induction principle is being used by the supercharger and turbocharger to forcefully induce the uh, air into the engine cylinder combustion chamber from the atmosphere. Okay? And here this supercharger will help for increasing the mass flow rate of air, okay, by providing more oxygen, and more oxygen will help for better combustion that would be available. That would not be because in the case of natural aspect engine, what happens? Okay, you don't have the external device called a turbocharger or supercharger where you don't where the air enters in a normal force like what is the atmospheric pressure, the same pressure it comes inside the system. But when you go for a the supercharger, what happens is the flow rate gets increased. Okay, so I told you the volumetric efficiency depends the ratio between mass flow rate of the air, which is in inductor to that of the theoretical mass flow rate of the air. So when the mass flow rate of the air inductor practically now I'm speaking when numerator comes it's a practical and when it comes to the denominator it becomes a theoretical. Practically is nothing but what is the during the operation of the engine in a practical condition. It can be in higher altitude condition or it can be in the lower altitude condition, irrespective of the condition. Okay, how much is the mass flow rate of the air which is induced into the system? That will have the the greater impact in determining the volumetric efficiency. Okay. Um, and when the supercharger, what is advantage is that it allows more fuel to be burned and more work. It's also we have seen it. Uh, Again, I told you this is not going to repeat in one cycle. Okay, this should be throughout the cycle till the engine is in on condition. Okay, when the engine is off, nobody is going to worry about that. And the main objective is to increase the power output of it. This is the key word. Okay, and again, you see here, the case of supercharger, what we are going to get is we're going to get the power mechanically. Okay, we are going to get the power that can be done mechanically. We are going to use different method like that. We're going to use belt method, gear system method, or shaft method, or a chain uh, connected to the engine crankshaft. So here, this supercharger will get the engine power from the from the engine itself. So here you are going to connect the supercharger with the help of a belt or a gear or a shaft or a chain to the engine crankshaft, and you're going to get the power mechanically. So you see again, we have seen the need of the supercharger, and again, we also see the purpose, and we will see it help of a drawing as well. So I told you to increase the mass flow rate of fuel, sorry, mass flow rate of the air before it enters to the cylinder, and again there are some questions which are coming up. Yes, can also be run by electric motor compatible. Yes, also possible. As turbocharger produces more power in a given system, the powertrain need to be modified to handle this increased power. Okay, so when the turbocharger is as turbocharger produce more power in a given system with the powertrain which is needs to be modified to handle this increased power. Will, will the so here the question is whether we need to modify the powertrain. Uh, no, it's like no, we don't need to increase the powertrain basically. Uh, we don't need to modify the powertrain because see powertrain again it not only deals engine it is the complete the transmission. Still it goes to the kill. Okay, so it has nothing to do with the modification of the thing. But say for example, if we are taking the power with the help of uh, the gears or shaft kind of thing, then then what happens is that you need to design such a way some modification is required with respect to the system in the engine only, not with respect to the transmission point of view or the powertrain. Powertrain basically it's combining of both engine and transmission. Yes, I agree we need to do the modification with respect to engine, but not with respect to transmission. Uh, so And again, I told you we are going to increase the power output for the given weight and irrespective of again, it also applicable to the different sizes of the engine. And we are going to increase the volumetric efficiency. And again, you see, we are going to compensate the loss of power due to the higher and this is the air which is coming into the system, okay, with the help of this supercharger. We are going to achieve all these things. So we have seen the thermodynamic cycle. Okay, the cycle. I told you the cycle is comprising of. So as we are nowadays we are dealing all with four-stroke. Okay, two-stroke we don't deal nowadays. Okay, but still an application. But now we are mostly dealing with 99% we are dealing with the four-stroke engine. When you're going for this four-stroke engine, with turbocharger and without turbocharger. With supercharger and without supercharger. Okay, so which means I'm going to compare the supercharger engine with respect to natural aspirate engine with respect to the thermodynamic cycle. Okay, so we have seen the pressure versus volume diagram, PV diagram we call. So in the case of gasoline, you get ignition. In the case of uh, compression or a diesel engine, you get a injection. You get injected. Um, so here, what happens is uh, you see, this is the stroke. Uh, you can see the air, which is first one is the induction stroke. Okay, basically the intake stroke, where the air enters into the cylinder, and you can see the pressure at which the air enters is getting increased. Okay? Whereas you see here, the case of the normal natural aspirate engine, okay, is coming in a negative direction. Okay, and you see here the atmospheric pressure when the pressure which is coming with higher force or with higher pressure. Okay, this is the difference you can find. Okay, and see, when you're going to have the higher intake pressure, which means the force is going to get induced systematically with higher force, will have the influence over the mass which is getting induced, and that will also help for the complete combustion to take place. Okay, that is the one. That is the advantage. Okay, you see here there is a complete shift is going to happen. Okay? And again, not only this one, and again the pressure which you are going to get uh, during the combustion as well, that also going to be higher in compared to that of the natural aspirate. Okay? Which means this will help you to have more fuel to get injected or ignited according to the cycle what you're going to use, or according to the fuel what you're going to use, and accordingly you get the pressure getting increased at each and every stages. Okay, you have the pressure during intake stroke, and you have some pressure during the compression stroke. You have the pressure which is there during the the power stroke. Okay, and again you have the pressure during exhaust stroke. The pressure at each and everything gets increased. Okay, basically we need to see the pressure up to the compression, which means during up to the power stroke. Okay, so again we have the increase in pressure because of the supercharger, where we are going to have the higher increase with respect to the intake pressure intake stroke, and corresponding this is also having the higher pressure increase with respect to the second stroke or compression stroke. And obviously this higher increase in the pressure what you're going to have the help of the expansion stroke during the power stroke, what you're going to have is that pressure is higher than the pressure what you're going to get using the natural aspirated engine. So we have different types of supercharger basically. We have and again, I told you this is a compressed one. Okay, I told you this supercharger is nothing but a type of air compressor. Okay, that's what I told according to the. So when I said it's a air compressor, it's basically a compression activity is going on. Okay, and again, you have two type of different type. You have two types basically. One is the positive displacement type, and the one is the dynamic compressor type. So again, this positive displacement is having different categories like twin screw type, and root type. Okay, and the dynamic compressor is having the centrifugal type. Okay, so when you take the twin screw or root, basically it is coming into the positive displacement type. Okay, will have the constant level of pressure uh, which will uh, which will increase at all engine okay, irrespective of the engine speed. Okay, when the engine speed is getting increased stage by stage, okay, throughout the engine speed, the positive displacement will help to have the constant level of pressure. Okay, pressure, and again the constant level of pressure will also get increased with respect to the engine speed increase. Okay. Whereas when you take this dynamic compressor, which uh, is the type of what you have for a centrifugal uh, supercharger. Okay, this will help in increasing the pressure with increasing the speed, which means uh, in the dynamic compressor, see, when the engine RPM gets increased, the pressure is going to get increased. But in the case of previous case, uh, the level of the pressure which it remains constant. Okay, and again the increase will happen the constant level of pressure, which means the pressure which is said to be constant with respect to the particular RPM will also vary with respect to the engine speed. Okay, uh, and again this dynamic compressor, which is a part of the centrifugal example. Okay, it's one type of supercharger. This will help. Which means with the help of increase of the speed or the RPM of the engine. Okay, that will try to accelerate the mass flow rate of the air. Okay, and what happens is the velocity. Okay, force is nothing but mass to velocity you call. Okay, and again when I say mass, it becomes force by velocity, and depending upon the force is nothing but means velocity is nothing but force into force divided by okay, how much is the force, which means uh, meter means how much is the uh, distance that at which the air strikes, that becomes the velocity of the air. Okay? And again, so again, force is nothing but mass into acceleration, and again, pressure is nothing but force by area. Okay, and all these are correlated: pressure, velocity, mass, acceleration. Okay, and here using all these principles, we are going to ensure that the air which is coming outside the atmosphere, when it comes to the inlet, we are going to have the induced force which is will meet all the parameters of velocity, pressure, acceleration, and also the mass. This is one example of the type what I have told. It's having the root type. The first one is root type, and second category is centrifugal type, and it is having the low basically. Okay. Uh, and this basically is an example of a root type turbocharger. So it basically uses the lobes, two lobes you have. So here the air comes inside. Okay. Uh, when it goes to the outside and pass through the lobes, uh, what happens is you they're making it to ensure that the force which is coming out is higher than what is the force which is coming before the lobes. Okay. Uh, so it forces the air into the intake manifold. That is the main purpose that we go with the charger. And again, this is the root type I told you. Next one is the compressor type. Okay. Uh, so when you go for the compressor type, you have different categories. Okay. Uh, so you have seen the roots, and you have again you have different category of the compressor type. Like you have a centrifugal type, you have a sculpting type, axial port type, you have the vane type, you have the roots type. Okay. Different company will select the different configuration depending upon the requirement. So we will see some of the limits or the drawback that we have for a supercharger. The, the supercharger will consume as much as 20 people will take the power from the engine crankshaft. Okay, and somebody are asking the flywheel is connected to the rear end of the crankshaft. Okay, so basically you're going to take the power from the crankshaft, which means what happens is this will consume almost again 20% of the engine total power output. Okay, that's why this can be overcome by the turbocharger. Okay, you don't need to take the power from the engine. Okay, but the advantage is I said the charge density can be gets increased. So here when you focus on the air point of view, uh, that supercharger will help actually. And the other drawback what we have is with respect to the increase in pressure. Uh, and when the pressure gets increased, the thermal load acting on the engine also get increased, and that will also increase respect to the rate of heat release. Okay. So considering this one, the supercharger will not have a better performance considering the higher pressure. Because when you have a higher pressure, you have the higher load acting on the engine, and again you have a higher heat release rate. So optimizing that, you have some drawback. And again, detonation it also gets increased because of SA. I told you, uh, abnormal combustion. Okay, there is a possibility is that abnormal combustion is the one where you have three type of combustion. One is the normal combustion, next one is the abnormal combustion, and third one is the retarded combustion. Normal combustion is the one where you have the fuel and the air gets ignited basically. When you ignite the fuel, the combustion or the combustion pressure shoots up. Okay, you need to ensure that the combustion pressure is not going to shoot up uh, above a normal case. When you go to the above a normal case, then you have basically knocking and detonation, what we call. Knocking is basically the case of the SP engine, and detonation should be basically the case of CA. Yeah, but here they compare the detonation and the knocking together, and they put respect to the SA engine point of view. Basically, they have considered the gas engine here. And for the case type of the turbocharger, we are going with the CA engine. And normally the knocking effect will be there in the case of the same. And this supercharger will also increase load on the engine. I told you, because of the thermal load, it will also increase strain. Okay, and again, this is kind of the help of a belt or a gear system or a chain system to the crankshaft. Okay, so even that this the increase of the load will also have the increase of the load onto the crankshaft. Okay, and again the design of the crankshaft. That's why you need to do some modification when you go for the thing like uh, you need to do some modification with respect to the crankshaft or anything like not the modification that you need to do with respect to the powertrain point of view. Okay, powertrain in the sense I'm talking about transmission. Is supercharger, turbocharger reduce the life of engine? No, it will not reduce the life of the engine, but this will in fact increase power output of the engine. And when you increase the power output of the engine, it will also help um, for you to achieve the required speed or the required power. We'll go with the concept called the turbocharger. Okay. So again, so people are asking, there are some questions is coming out. Is the best type or what is the advantage of one type or other? Okay. Uh, so here, what we normally go with, we select either go for the vein type that is mostly used, and even the lobes are also used. Okay, and again here we have different types, and again the selection is also based on not only with respect to the performance but also the cost point of view. But what I have seen in present scenario, people go with the displacement type, okay, where they want to go with either vein or uh, even the screw method also they go, but this configuration becomes a bit complicated. Uh, and, and again, even people are also going to centrifugal diapers. What purpose of saying is that going with the roots and the screw is becomes complicated. But some of the OEMs also trying. I'm not saying this is best for this or this is best for that, but based on the system design and also the less complexity, I'm saying that the significant win. And again, this turbocharger is having again different category. Okay, um, and again you need to see the flow. Okay, how the flow is going through the turbocharger. Okay, and here it is having different components. It is having the compressor. It is having the housing. It is having the turbine. It is having the shaft. Okay, so the different components that we have in the turbocharger. I will show you some of the video before. Okay. I will just explain the concept, then I will go with the video. So this is the layout of a turbocharger. This is the compressor. This is the turbine. This both are kind of help of a shaft. Okay. So you see here, the compressed air comes to the compressor, and it goes here. It will not go directly to the deck manifold. You have the intercooler. Okay. You have the intercooler. This will increase the torque density of air. Okay. And when the charge density gets increased, even this intercooler will help you to increase the volumetric efficiency of the engine. Okay, and when the air goes here, the combustion will happen. Okay, and the exhaust gas will come from the exhaust manifold, and it goes before it is going to the atmosphere. Since you are using the turbocharger, the exhaust gas will go to the turbine. Okay, so when it goes to the turbine, what happens is the turbine rotates. Okay, I told you the turbine and compressor are kind of shaft. When the turbine is running or rotating at higher RPM, gas of the exhaust gas is coming here, which means the speed at which comes the exhaust gas strike the turbine blade, because the turbine is having different blades called turbine blade. Okay, when it strikes the turbine blade, what happens is the speed at which the turbine blades or the turbine rotates will be more than 1 lakh revolution per minute. That is the max. That 1.5 or more than 1 lakh revolution per minute. Okay, that is the maximum level of speed at which the turbine will rotate. Okay, using that much speed, when since it's connected to the shaft, okay, what happens? The compressor also rotates, and this will suck more air. It will be forcefully to induce. Okay, so that's why I told in the initial slide itself. We are going to use the concept called force induction method to take the air, suck the air from the atmosphere, where we are going to increase the atmospheric pressure. Okay, and the cycle repeats actually. This cycle repeats till engine is going to the stop mode. Okay, and again, okay. So I told you again, you are going to increase the volumetric efficiency because you are going to increase the mass flow rate which is coming to the system. Okay, and we have some benefits and also the limitation even in turbocharger. We'll see what are the advantages and what are all the disadvantages. With respect to the power, when you are comparing to the same size of naturally aspirated engine, your power output gets increased, and you're also going to have the better thermal efficiency compared to that of naturally aspirated engine, and even the supercharged units. Okay, because there are a lot of load, okay, which is coming into the supercharger also, but that can be overcome with the turbocharger. Even there are a lot of questions that is coming from the participants, whether supercharger is better or turbocharger is better. So now we are going for all most of the vehicle we are going with the turbocharger one. Even the turbocharger is also having a different variety like a single stage turbocharger or two stage turbocharger. Even those things also been used by many OEMs. Okay, and this is going for better fuel economy because we are going to increase the power output. Okay, which means the mileage of the vehicle. Okay, mileage of the vehicle can be much more better, and obviously the volumetric efficiency. You can also increase the speed. Okay, and again you can also average the overall average level of the output also going to be taken and then are going to maintain it. And what are the limitations? Okay, this engine weight will increase. Okay, because it is having the it is a separate part actually. If there will be any improper maintenance, then there will be a problem in turbo called turbo lag. And sometimes the turbo noise called whining noise also will happen. Whining noise in the sense when the vehicle is when the engine is running in higher RPM, okay, the turbo port, the turbine, the whining noise, the whining noise is like a whistling noise, uh, and the whistling when you whistle it with higher force, how the sound, that whining noise, okay, you can see how the whining noise will also look. Okay? It is just like a whistling noise, but it's with higher force. Uh, and again, we need to balance the system also, okay? Because we have the turbine, we have the compressor, we have the shaft. You need to balance, okay, and balance it in a proper manner. Otherwise, this will also lead to the turbo lag. But this turbo lag can be overcome with the variable geometry turbocharger. So this is the conventional turbocharger. We call two type of turbocharger. One is the normal turbocharger, and another one is the variable geometry turbocharger. And you also have a wastegate turbocharger. I will explain that later on. Okay. Again, so the turbocharger is considered to be the traditional one. Okay, and in that I told you you have a lag called turbocharger lag, and it is also known as the turbocharger transient response time. Uh, so here we are going to consider the aspect ratio. Okay. A by R. The aspect ratio is nothing but you can also call it as A by R ratio. And how I can define the A by R ratio or aspect ratio. a constant. So here we can define the aspect ratio as the ratio between the intake passage of the turbine. You have turbine and also compressor as a part of both it. Okay. So here in case of turbine, what I'm going to take is, and you assume here you have the system like this, and you have the system like this. So when the system is like this, you have a larger aspect ratio. Okay, and when the system is like this, you have smaller aspect ratio. You see here because uh, you have lesser space. Okay, and again. So how I can define this aspect ratio? It is defined as the smallest cross-sectional area. CSA stands for the cross-sectional area. You can see the cross-sectional area of this is higher than this one. Okay, so when the cross-sectional area is smaller, which means you have the smaller aspect ratio. When the cross-sectional is higher, you have higher aspect ratio. That's why you see here aspect ratio is defined as the ratio between the smallest cross-sectional area of intake passage of turbine housing to that of the distance from the central turbine wheel to the centroid of area. So when you consider the turbine, okay, uh, that is basically a wheel. Okay, it is of circular shape. Okay, and that turbine will have the centroid. Okay, and the distance from the central turbine wheel to that of the centroid foot of the when you have the area for that. Okay, centroid of the area, then this becomes the aspect ratio. And why this aspect ratio is very much important is um, in case of turbocharger, since you have the turbocharger lag, and which is nothing but with respect to the time, you also have the lag. Okay, basically when the engine is running in higher RPM, okay, you tend to have the issue of the turbo lag. Okay, and this will also affect the aspect ratio of your turbo system. Okay, and that will also have the corresponding decrease in the power output of the engine because of the various problems with respect to the throttle and the response time. Okay. That can be overcome with the help of the modern turbocharger called variable geometry turbocharger. Again, here, in the case of turbocharger, when you have a turbo lag, turbocharger lag is shortly called turbo lag, and this turbo lag also happen because of the inertia of rotating part. Okay, you, turbine is rotating, compressor is rotating, and again you have a shaft. Okay, because of all these rotating parts, what happens is you are going to develop the inertia because of the turbo lag, and again the efficient projection of exhaust gas also will get affected when it is passing to the turbine vanes. So these are the issues that we have. Okay, and the need to overcome this turbo lag or turbocharger lag is to go for a variable geometry turbocharger. This is the system of having a variable geometry turbocharger. Okay, so as the name itself indicates, variable geometry. We are going to vary the geometry. What geometry we will see? Okay, uh, see the name indicates the variable geometry, which means we are going to vary the geometry. We are going to vary some geometry. Okay, what is the geometry? Uh, that geometry will help. I told you, you go with a variable geometry. There are a lot of advantages are there by modifying this geometry. When you're going for the VGT, shortly called variable geometry turbocharger, shortly called as VGT. When you're going for a VGT, it has a mechanism by which the inlet air area means the air. Okay, basically area. This inlet area is nothing but a air where it comes to the outside. Okay, but this inlet area can be varied to obtain the required aspect ratio for a given flow rate. Okay, so whereas in the case of previous turbocharger, the aspect ratio maintaining the constant aspect ratio is somewhat a problem. Okay, and again you have I told you it all depends on various factors. One of which is the turbo lag and design itself. Okay, I told you, you need to, when you're considering the turbine wheel having some circle, having some diameter. Okay, and and again, you need to consider the centroid. Okay, centroid of the particular turbine. Okay, and maintain the constant aspect ratio becomes the case of about that engine. But here you see, um, the turbo VGT, it has a mechanism by which the inlet area can be varied. Okay, the area where the air enters can be varied, okay, to obtain the required aspect ratio for a given fluid. Okay, so it can either increase or it can either decrease. Okay, which can be varied means what is the meaning of the word? It can be varied. It can be varied, which indicates it can be made either low side or it can be made higher side, and that can be obtained from the given flow rate. If the mass flow rate of the air is more higher, then accordingly the aspect ratio can be made it. And when the mass flow rate of the air is found to be lesser, accordingly you can also reduce uh, the area of the need of the third. Just a minute. Just hold for a minute. Okay. So with the help of we told you you're going to vary the size. It means you're going to vary based on the aspect ratio. So here in the help of variable geometry topology, what you're going to do is that you're going to reduce the aspect ratio at low engine speed. Okay. When see what is the meaning of low engine speed? It is nothing but you're going to have the exhaust flow very low. Okay. And what is the meaning of the one when I say when the aspect ratio is higher? Okay, which means you're going to have exhaust flow which is going to be on the higher side. Okay. Uh, so I'm going to modify the aspect ratio, which is not possible in the case of a turbocharger. There is the comparison was being done between the variable geometry turbocharger and conventional turbocharger with the help of the simulation activity. Because it is being carried out in 7.3 liter diesel engine. Uh, Basically, the simulation is being carried out. V8 configuration, uh, direct injection. Again, the vehicle used is international class. This is like Delta truck vehicle. Okay. Um, so we will see the comparison between what are the parameters difference that we are going to experience between a variable geometric turbocharger and then the conventional turbocharger. Okay, that we will see it. So this is the configuration and then the specification of the truck having the gross vehicle weight ratio of weight is 7,950 kg, the weight of the vehicle. This is the wheelbase. PG location is this. Frontal area of the vehicle is 5 meters square. The air drag coefficient is 0.8. And this is a 4-speed automatic gearbox. And I told you it's a V8 engine. Having displacement of 444 cubic inch. In the bore, stroke, output of the engine, power output, torque output, everything. And the governing engine speed is 2000 rpm. That is a specification of the vehicle. They are going to compare the vehicle with VGT and with the turbocharger. Okay? And they are going to test the engine. First, the result is being carried out with the VGT, and the result is carried out with the conventional. And here, uh, for both tests or both type, what they consider is they're going to consider the engine will run at the full load. Okay, because when you compare the test with one system to other system, the conditions should also be same. Okay, it's not that you are going to do the test with different condition and you are going to compare the output. Okay, so now to have the same comparison between the normal turbo and then variable geometry turbo, you need to come the even the test also in such a way what to test what we are going for. One system should also match the other system as well. Okay. Uh, so here in both the cases, the engine is also accelerated between 0 to 60 miles per hour. Even this condition also remains same. Okay. And again, the fuel injection time is also kept same for both the cases. Okay. You see, because this is very much important. Okay. When you do the same condition, then only you understand whether variable geometry is better or old conventional turbo is better. Uh, in what aspect this will be better or that better. Okay, because when you test it different condition, then you cannot get you cannot compare basically, and this is possible only with the help of simulation. But when you go for a real condition, it becomes very difficult to give the same level of input for both VGT and the conventional turbo, because there is a possibility the alteration can happen with respect to many aspects. Uh, and even when you take the vehicle to the higher altitude, having the places like Manali or Ooty, where altitude is higher. So when you take the vehicle where you can test one with VGT and the same vehicle can be tested on turbo, but when you test the VGT with VGT possibility, the pressure can be on the higher side, or the pressure condition also will vary. You know, when the altitude is higher, the pressure is lesser side. Okay, even though there is a less pressure, okay, there is a possibility just with a different time. Okay, say for example, the pressure at the morning may be different, afternoon time may be different. Okay, but even though the altitude is having lesser overall pressure, even the pressure itself will vary with respect to the different scenario. Okay, even for that matter, even when the vehicle is running in a normal road without higher altitude, even you can apply the same principles there as well. Okay, so that's why it's very important. This type of results can be much more effective when you can compare the proper simulation. That's why they've taken the boundary conditions and they've given the proper simulation. And again, they also applied considering the time and also the maximum speed, and they also given the torque requirement, and they made it equal for both the cases, respect to the speed, vehicle speed, engine speed, and then the fuel injection cycle, and the ratio, whether it is coming in real mode or rich mode or equivalence ratio against the time. They made it everything equal. And you see, this is the overall comparison between this is a test result basically. Okay. See, I'm going to compare the engine speed between the variable geometry and the conventional vehicle or the conventional turbocharger with respect to the time. It's nothing but second. Okay. With respect to the, see, normally I would take a second. The dotted one is nothing but the conventional turbocharger. The thick line is nothing but variable geometry turbocharger. You can see the engine speed is going to increase when comparing to the term normal turbocharger. Okay. And this is because the aspect ratio what I told. Okay. And when the engine is running in low RPM, okay, where you get low pressure, okay, or low force. Okay. Um, Against that, the aspect ratio is not going to be made to of the turbocharger. When you go for a very big geometry turbocharger, where you are going to adjust or you're going to is that considering the frequency will increase and at low basically with respect to the low RPM, what happens is the pressure will be lower. So this boosts the pressure basically. Okay, this variable geometry basically, when I say there is increase in pressure, it's starting with a boost pressure. Okay, you're going to increase the boost pressure at ideal RPM. I mean, during the start of the vehicle. Okay? Correspondingly, I can also compare the boost. I told you we are going to increase the boost pressure. You can see the boost pressure is going to be when the engine is running in idle RPM. Means during the start of maybe maximum of 10 seconds. Okay, those first 10 seconds will be quite very important. That will, because you need to have high boost pressure. Okay, this will also increase the pickup acceleration of the vehicle. So that is the advantage that you have when you go for a variable geometry turbocharger. And again, you also have the turbo lag, and sometimes even the turbo whining noise can be avoided when you're going for the variable geometry. But even the noise, as far as noise is concerned, there is no scientific evidence that the turbo, because here also you get the noise, but there is no scientific evidence that a conventional turbo is having more whining noise at the top of the variable geometry turbo. Because even in VGT, there are some cases where we get the noise, it's a whistling noise. Okay, that becomes very peculiar. And again, the reason is very difficult to understand on what basis when you get the whining noise or the whistling noise. Okay, and even you would have seen some of when you observe the vehicle, you sometimes to observe the whistling noise or the whining noise, you need to have deep concentration to find out whether the noise is coming from the engine or the noise is coming from the turbo, or is it because of the higher speed the noise is coming from the engine. So it is like very difficult to categorize the noise category. Okay, so it becomes very peculiar. It becomes very sometimes you need to have observe high level of concentration, and still um, the observation again it needs more concentration to observe to find out the noise is coming from the turbo or from other aspects as well. Okay, and again, this will also increase the vehicle speed because you're going to increase the engine speed at the lower RPM. Okay, and you can see up to 40 seconds, this the vehicle speed can be higher. Okay, and similarly, the air fuel ratio or fuel to air ratio equivalence. Okay, that is also going to be higher during the initial seconds, initial time for variable geometry procedure, and it is going to be corresponding for the, the, the okay. So again, when I compare the back-to-back variable geometry turbocharger and the conventional turbo, so the turbocharger lag can be eliminated by using the variable geometry turbocharger because of higher boosting pressure at low speed. If you have a high boost pressure, you okay, and again that will also um, will help you to maintain the aspect ratio of your vehicle of your engine. There is no cost penalty in using the variable geometry turbocharger. And there's no, you're not going to increase the cost also too much. Um, and there are a lot of performance improvement as well. And again, this VGT will help you to improve the fuel efficiency. Okay, and it will also help you to increase the transient response, missions, and torque ability. So you have a lot of advantages. And see, when you're going for a variable geometry, so that will help you to increase the pressure. I told you it's nothing but a boost pressure. When you increase the boost pressure, all the advantages are there. Basically, this is good for a low speed application. Okay? And uh, and again, you see here the takeoff speed of the variable geometry turbocharger engine is also higher than conventional one. And this variable geometry will play a vital role in the future energy recovery, which means again, with respect to the fuel efficiency, the fuel improvement, the mileage, okay? Full fuel efficiency I want to get. And and the last important thing is that you're also going to consider cost benefit analysis. This will also determine, because again you're not going to increase the cost also using variable geometry. There will be slight increase in the cost. I'm not denying that, but finally we have a lot of advantages with respect to, yes. Only the reason is when you go for a low speed, especially when the vehicle is running in altitude. Okay, already the pressure will be less at altitude. Okay, and still when you are when you have a normal turbocharger without waste gate, okay, what happens without variable geometry? Okay, what happens is there is a possibility that pressure will be much more lesser. So to avoid those skins, the boost pressure uh, can be increased with the help of the VG. There are some noises because of fuel balance. Yeah, even that is also possible. Okay, the flywheel balancing is also very much important. That's why it's very difficult to find out whether noise is coming from the engine point of view. Even there may be chain noise also may be coming from the engine. Okay, but sometimes it's like when you whistle. Okay, something whistling. Now I'm doing the whistling. So when the same whistle when you are going with a high speed. Okay, but is it possible to find out the noise because the engine speed will be higher, and again you may get some the noise which is very difficult to predict actually. Okay, see I'm whistling now. Okay, but because of the higher speed, sometimes the whistling noise is very difficult to identify it. But sometimes when you go with a high level of concentration, there is a possibility. But again, there are some equipments are there where some of the OEMs they try to uh, put the NVH aspect into it, where they also find out what is the decibel sound which is coming out of the turbo, which is basically in the form of the whining noise. So people are doing that. Uh, that is one problem that we have to identify. The noise is not only because of one. Yes, of course, I agree. Flywheel also contribute, and again, not only from turbo, even the chain or other systems. There are a lot of things will also have the noise. Okay, uh, and this fuel economy better than conventional. Then okay, that's why I told you. Basically, the fuel economy or fuel efficiency is much more better when comparing to that of it's better for a VGT when compared to the turbo. We have the turbine and compressor. Basically, when the exhaust gas is coming to the turbine, okay, this rotates the compressor and the air comes. So, what I told you. Okay, and whatever I told orally, it comes as a theory. And I also told you that the speed at it runs the turbine is almost 1 lakh RPM, and it also can run up to 1 lakh 50,000 RPM. And what can go wrong? See what can lead to a turbocharger or a turbine damage? Okay, it can be because of the post piston ring or valves, anything. Okay, and what can go wrong, especially the compressor. So these things I have uploaded. Now we'll see the waste gate. Then I will go with the videos. Okay, this boost pressure is very much important. Okay, and this both the supercharger and turbocharger one we need to design to ensure that we are going to increase the pressure which is greater than the atmospheric pressure. Okay, that is the main objective, to increase the pressure when compared to the atmospheric pressure in the intake manifold, and that is the key objective. Okay, irrespective of the system what you are going, you need to ensure that we are going to increase the pressure. That is the first key thing that we need to look into it, and we should also ensure that that will have the fact with respect to the combustion point of view, the combustion chamber. This also I told you. Okay. And this will also increase the charge density of your engine and this will increase the engine power. This also I have told you. And here the amount of boost or the boost pressure. Okay. I told you the boost pressure. I also given you the comparison between variable geometry turbo and the normal turbo. Okay, where the variable geometry turbo is having the high boost pressure and the engine is running with start of the period. Okay, and what is the unit for this boost pressure? Okay, that, and again, that, the unit is also very much important. Okay, how in what way you're going to consider pressure? Basically, the boost pressure it can be measured in terms of bars. Okay, and again, here you consider the atmospheric pressure, where you consider the mercury, and then you can also consider the pounds per square inch, or the megapascal, or the millibar. Okay, but normally millibar will be the mostly used values when you're going for any trials. Or the waste gate. Uh, Here, I told you the turbocharger uses exhaust gas, because when the exhaust gas is striking the turbine, what happens is it rotates at a higher RPM. Okay, when it rotates at a higher RPM, it will increase the boost. Okay, and when it increases the boost, what happens is it will cause the engine to make more exhaust gas again, and which will also in turn will increase the boost pressure of the overall system, and which is coming from the turbocharger. And again, there is a possibility if the boost process goes higher. Okay, so here you need to understand very important thing. The boost pressure should not be too high or should not be too low also. So here we use the system called wastegate. Why we need to use the system called wastegate? This will help the turbocharger to prevent overboost. And even when there is overboost, also problem. Okay, because and this will strike the turbine and it will also cause severe damage also. Okay, and to prevent overboost and the severe engine damage, most of what they use here wastegate. This is the main reason. Okay, to avoid the overboost. That is very much important. And when, to prevent low boost, we go with the variable geometry turbocharger. Okay, when you go with the variable geometry turbocharger, the boost pressure gets increased. Okay, but the only challenge is that the engine is running at higher RPM. Okay, where you need to where you have the possibility that the boost pressure of your engine gets increased in such a way that will also damage the turbine blades. Okay, um, so that's why you need to go for a control of the boost, for which the wastegate system is very much used. This wastegate is again it says valve. It is like a actual it's a valve basically, similar to a door that it can be opened and closed. Okay, you can open and also you can close it. Okay, and when you open it, you can increase the boost pressure, and when you close it, you can reduce the boost pressure. And according to that, it will think. Okay, and again this is again adjustable one. Okay, the best case is again it's a bypass valve. It's connected at the exhaust inlet to the turbine. I will explain that with the help of a drawing. And again, it allows the wastegate will allow all the exhaust into the turbine, or it can also route some of the exhaust past the turbine to the exhaust system. With the help of this drawing, I am going to explain. Basically, this wastegate is been first used in a Duramax diesel controlled maximum distress. First wastegate system. Okay. Here, what happens is this is the turbine, this is the compressor. So when I say compressor, it's related to air. When I say it's turbine, it's related to the first gas. Okay. Uh, when the exhaust gas is coming at striking the turbine, okay, what happens is higher the flow of the exhaust gas will have the highest high level of boost pressure as well. So when you go for a wastegate, when you open the wastegate, what happens is when you open the wastegate, what happens, and when you close the wastegate, what happens? Okay, you see here you have the valve kind of thing. When you open the valve, okay, when you open the valve, the exhaust gas which is coming will go to the turbine and make sure that uh, it will rotate the turbine wheel basically. And when you go for the valve in a closed condition, which means the wastegate in a closed condition, what happens is uh, it will not allow the flow to strike the turbine, that it will go and again it again goes to the exhaust. Um, so by this way, the waste gate system will help the system not to increase the boost pressure, and it will control. Okay? And this can be done with the help of the valve. I told you it's a valve basically. And again, the valve is also having different uh, category. Basically, we are going for a relief valve. And again, you have two types. One is a compressor bypass valve, or it can be the blow-up valve. Okay, what is that relief valve is all about, and what is the function of it? Okay? So the valve basically the function is to open and also to close, depending upon the boost pressure what exhaust gas is going to deliver. And when the exhaust gas is coming with high boost pressure, then this will get closed, and this will open when we have the normal boost pressure. Okay, yeah, relief valve it vents the pressurized air from connecting to between the outlet of the turbocharger, and you also have the throttle. Whenever the throttle is closed during boost, I told when you have the high boost, okay, the valve will be closed, which is nothing but the throttle is closed. Okay, the throttle is nothing but uh, lever kind of thing. It will be in the closed condition when the boost is in the highest side, and again it will it run to different um, shift here is the valve opening and then the valve closing. Valve opening in the sense it will open when the boost pressure is coming to the normal or required boost pressure. Okay, and it should not also be in closed condition always. When it is in closed condition, always what happens is you will not get the enough boost pressure also. Okay, so it's very much careful uh, while selecting the valves also, and there is a possibility the valve can struck. And the valve gets struck, there is a possibility the boost pressure will get struck, and again this will also affect your efficiency also. Um, it's one of the dual turbocharger engine installed on a Chevrolet V8 engine. So this also I uploaded. You can take it. Okay, is this manually adjustable? Yeah. So here, your question is adjustable kind of thing. So it's basically you have the response based on it's basically electronically controlled wastegate. Uh, so what happens is depending upon the boost pressure, the value what you're going to get from the exhaust gas. So you get the value, and again that is sensed accordingly. It is again programmed with the help of the control unit system. So based on that, when you find the boost pressure higher, you get the response that the valve should be in closed condition. So accordingly, it is electronically controlled, and that valve or the throttle gets closed when you get the sensing that the boost pressure is on the higher side. So it's not according to me, but in olden days I started with manually adjusted one, but now it's completely electronically operated. It adjustment is happening electronically. Uh, is waste gate only for conventional turbo? Uh, so I told you the main purpose of this waste gate is to avoid overboosting. Okay, there is a possibility that the conventional turbo what we are using also having some issues over the variable geometry turbo. But considering that even you have the turbo lag and whining noise, uh, but we are using the wastegate where the the requirement of the boost pressure control is very much important. If you're not controlling the wastegate to the level, then it also creates the issue of the basically the loss of system, or this will also contribute to the higher fuel efficiency point of view. And again, it will be fine tuned to operate depending on the required power. Yes, you need to do some fine tuning as well. And again, for which you need to calibrate your engine. You need to do some calibration where the calibration row comes into picture. Going to use the force emitter, and you're going to forcefully induce the air. And there are different parts of turbocharger we have. We have the housing of compressor for housing the wheel of a compressor and turbine wheel. Turbine housing, we have shaft, we have bearings, we have oil seals, and all these are integrated together. So here we have the middle part, which has been handled with the help of the shaft. Have the turbine wheel, you have the compressor wheel with the help of the shaft. You connect both the things, and when the turbine wheel is rotating, the compressor will also start rotating, and the speed at which the turbine rotates is 1,50,000 kilometers. Sorry, 1,50,000 RPM. And here we have the bearings and oil seals for lubrication and to avoid friction. And you see, in the case of naturally aspirated normal engine, you don't have any external device, or you don't have the forced induction principle. So you have the normal combustion, which will happen with the help of the piston, where it moves up and down, the power gets produced. But when you go for a turbocharger, you have the exhaust gas when it is coming out with high pressure, and here you have the chances of getting more power because you are forcefully inducing the system. And you see here, the important thing is that I showed you some of the block diagram when I'm giving for a theory class. I was giving you there is a presence of intercooler between the compressor and to the engine intake system. Okay, because of the exhaust gas which is coming from striking the turbine blade, what happens is that the compressor, where the air is very, the temperature of the air is lesser, means the normal temperature what it comes from the atmosphere. Okay, because of this exhaust gas, uh, even the temperature of the compressor is going to be higher. Okay, you can't use that high temperature air directly to the system, intake system, or into the engine. Okay, so what you have to do is that you have to reduce the temperature of the incoming air before you pass that to the before you pass that air to the engine system. Okay, for which we need to use the intercooler, which will reduce the temperature, and it will also increase the charge density. Okay, uh, so I given the principle of the charge density. Okay, when you increase charge density, what happens is that you're going to increase the volumetric efficiency also. This is the reason why we go for intercooler. Because when the pressure is getting increased, your temperature also getting increased. Okay? So you need to reduce the charging, the air temperature basically, and you need to also increase the charging density. So this is the where you are going for intercooler. Intercooler is nothing but a heat exchanging device. It will reduce the temperature of the air, and it will increase the charge density. Will increase the charge density, and by you are going to increase. So here you see it is very much important. You have the difference between the intercooled air and the turbocharged air. When you go for a turbocharged air, what happens is you have high temperature and less charge density. And when you go for the intercooler, you normally increase the high charge density, okay, but and temperature gets reduced. And when you go for a supercharger engine, instead of turbocharger, when you're going for a supercharger, okay, you don't need to have the intercooler because you directly you have the high charge density. Okay, I given you the principle. Okay, I given you the when I'm giving the expansion of explanation of a supercharger one. What happens is that will increase high charge density itself. Okay, uh, that is one thing that you can go look when you're going for a supercharger. But there are a lot of other problems that the supercharger also having because you need to take the power from the engine, which means 20% of your power gets lost because to drive this you need to take the power from the engine. Engine output basically cranks up. Okay, that becomes very difficult task. Okay, and also you are going to put lot of load into the engine. Uh, that is also a problem that is having. And again, I told you this book, when you go for a the valve kind of thing, wastegate kind of thing, uh, the variable geometry turbocharger. So when you go for a variable geometry turbocharger, I told you, uh, when the engine is running at low speed, your boost pressure gets increased. And again, when you're going for a bit, what happens is when the engine is running in the higher RPM, okay, sometimes what happens, extra excess boost is not required. Okay, that you are having the valve that will control, that will stop, and it will open and it will close. Okay, when the boost pressure is higher, it will close, and when the boost pressure is normal, and it opens and it goes to the turbine and it operates.